so basically, we have this chain rule problem here. But you have to realize that the main idea of this problem is actually not even chain rule. Okay? The main idea of this problem, the first one, is actually product rule. Okay? So I'm taking the derivative of x squared times e to the 2x. So there's a chain rule with the e to the 2x part, but the main idea of this is product rule. So when we go to take the derivative of this, that's how we start. We start with x squared times e to the 2x. So product rule says I take the derivative of the first, 2x, times e to the 2x, which is the second, plus the first, x squared, times now the derivative of the second. This derivative is where I need to do chain rule to find this part of the product rule. So the main idea really isn't chain rule. The main idea is product rule. I just have a chain rule inside. So I'm going to come over here and do the chain rule for this part, where the inside function is my 2x and my outside function is my e function. Okay? So now I do chain rule. So we get dy over du equals e to the u, because the derivative of e to the u is e to the u. And then du over dx is 2. Then we multiply, so we get 2e to the u, which is 2e to the 2x. And that's what we put here to finish up our product rule. And that's the derivative. So sometimes chain rule is our main rule. Sometimes we use chain rule inside of another rule. So technically we have chain rule here, but it's inside of a product rule. Okay? Now the next one. Find the derivative of y equals cosine x sine 2x. Again, this is another example of we have a product rule, but inside of my product rule, I also have a chain rule because I have this 2x inside sine x. And there's this multiplication here, cosine x times sine 2x. So again, I start off my derivative by doing product rule. So the derivative of cosine is negative sine x times sine 2x plus cosine x times the derivative of sine 2x. And again, this is where I have to do chain rule, is inside of my product rule. And again, inside is u, so 2x is u, y equals sine of u. The derivative of sine u is cosine u, and the derivative of 2x is 2. We multiply them, and we get 2 cosine of u, which is 2 cosine of 2x. And that's what we put here. And that finishes out our product rule. So sometimes our chain rule is our main derivative, sometimes it's a supporting derivative rule. Okay? And remember, product rule is one of those rules that a lot of people forget. Okay? Now, the next one. This f of x, we're taking the derivative of this. Here's the two ways you can do it. We could, if we wanted to do it this way, and just simply do the derivative using quotient rule. Okay? So if we did quotient rule, we'd get the low function, which is secant x, times the derivative of the high function. And as soon as we do that, we got to do chain rule, because I have natural log with x squared inside of it. Now, you could do this one. We did this one yesterday. Okay, so there's two ways of doing that. You can either do chain rule or you can move the 2, but let's do it chain rule just so that you could see it. So we have to take the derivative of this. So my u is my x squared, which means y equals ln of u. The derivative of the natural log of u is 1 over u times the derivative of x squared, which is 2x. Plug the u back in, we get 2x over x squared, which is 2 over x. And that's what we put right here. So that's the derivative of my natural log of x squared minus natural log of x squared times the derivative of the low function, and the derivative of secant is secant x tangent x over the bottom squared, which is secant squared x. So this is my f prime. Now, I would never do it that way. If you follow your 4 steps, the first step is to rewrite. I would have rewrote it like this. Because dividing by secant is the same thing as multiplying by cosine, correct? Using trig. So I'm using a trig identity here to change this quotient into a product, which makes my derivative a lot easier. So again, derivative of the first would be negative sine x times the natural log of x squared plus cosine x times the derivative of this, which we already know is 2 over x. Okay? And you can see really easily, this is this part right here. If you split it apart, if you split it this and this, you'll see that you get this and this. Mm-hmm. Yep. Okay, and then the last one. Okay. So again, I have chain rule here. Okay, so this one is a special case because when I start doing this, I'm going to rewrite this first and foremost, because as soon as I see this root, I need to change it to the 1/2 power. Now I have chain rule going on, right? I have this function tangent this function on the inside and that one on the outside. So again, I rewrite u is tangent x squared and y equals u to the 1/2. Okay. Now, this is where it gets interesting, because now I have to do the derivative of u, but I have a function inside of a function still. So I have to split it up again. So let's say v equals x squared. That means u is tangent of v. Nothing changes. We still take the derivative of each one. So dy over du equals 1/2 u to the negative 1/2 power. Then du over dv equals, the derivative of tangent is secant squared v. And then dv over dx equals 2x. And basically, now we just multiply them. We multiply all three. Okay? So dy over du times du over dv times dv over dx. This and this divide out, this and this divide out, which leaves us still with dy over dx, which is 1/2 u to the negative 1/2 power times secant squared v times 2x. And then we can't leave it with u's and v's in here, so we get 1 over 2 square root, and remember what u is, that's tangent x squared, times secant squared, and what v is my x squared, times 2x. And when we finish, by simplifying, we get 2x secant squared x squared all over 2 square root of tangent x squared.